Okay, today we're going to start talking about our electromagnetic waves. You need to fill out the note form that I gave you as I go through this PowerPoint. Right, electromagnetic waves consist of vibrating electric and magnetic fields that move through space at the speed of light. The speed of light is 300,000 kilometers per second, the speed that EM waves travel through empty space. We've talked before already about how electromagnetic waves don't require a medium to travel through. That's why we see stars and we get light from the sun, our closest star. Let's label now the electromagnetic spectrum. You first have the radio waves. That's like your radios, your TVs, your cell phones, and microwaves are even included in this section. Your infrared rays, which are heat rays, your thermograms. Visible light, which is actually a very small section on the spectrum. And we use Roy G. Biv to help us remember the colors: red, orange, yellow, green, blue, indigo, and violet. You have ultraviolet rays, which are from the sun. X-rays, which I think everybody probably knows what an X-ray is, so I put on there that it can cause cancer. And gamma rays, which is what people receive when they go through cancer radiation. Let's talk about light a little bit. When you see something, it's because that is the light that is being reflected off of the object. When the light strikes an object, it either has to be reflected, transmitted, which means it goes through it, or absorbed by it. When you look at the red flag, all other colors are being absorbed by the particles that show red, and the red is what's being reflected back at you. We have three types of material I want to talk about: transparent, translucent, and opaque. Transparent materials transmits most of the light that strikes it. The window is a transparent material. Translucent materials scatters the light as it passes through, so you can see the light, but it's going to be kind of blurry. The snowflake on my window is translucent material. And last, opaque materials, which reflects or absorbs all of the light that strikes it, so none of the light goes through. My lab table is opaque. Now let's talk a little about how we actually see the light through our eyes. You first have the cornea, and that's that clear front surface of the eye. This helps to protect the eye, and it helps kind of focus the light in. Next is your pupil, and that's the black part of your eye. And that's actually an opening. And that opening is what allows the light to enter into it. And around that opening, you have the iris. The iris is what gives your eye the color: green, blue, brown, hazel. And that is just a ring of muscles. And all it does is control the size of the pupil. So it'll contract to make the pupil smaller or relax to make the pupil larger. It depends on the amount of light that is coming in. So when you walk outside in the sun, it'll contract, giving your pupil smaller. And if you walk inside into the dark, it'll relax and opening it up. This is the reason why it always hurts your eyes whenever you walk outside after seeing a movie. The lens was that white part right behind the pupil. And your convex lens is what refracts the light to form an image. And it's held in place by ciliary muscles. So it's just right there in the middle of your eye with those muscles holding it up. Next is your retina. And the retina we had labeled on the back of our eye. And on the retina you have a layer of cells that all inside of the eye. And it is what forms that image that's upside down. The rods are cells that respond to dim light, and the cones are cells that respond to the bright light and color. So the retina is made up of both rods and cones. There is one spot right at your optic nerve where there's not any rods or cones, and that's what we call our blind spot. The optic nerve is what goes from the eyeball up to your brain, and that's where the information gets sent to in order for you to be able to determine what it is that you are seeing. Nearsightedness. Some of you guys wear glasses because you are nearsighted. So if you are nearsighted, you see near. You can see things that are close up, but not at a distance. And what that means is that your eyeball is too long, and the glasses that you wear are concave lenses. Farsightedness. Farsighted means you can see things far away. So close things get blurry. These are people that wear reading glasses. That is when your eyeball is too short and you have to have a convex lens to correct it. Telescopes use light. They use lenses and mirrors combined. You have refracting and reflecting telescopes. Your microscope will use a combination of lenses. Cameras uses lenses to focus the light. Lasers are all the light waves of one color or one wavelength. We have reflections. We talked about reflections before. And we know that we have regular reflections. We talked about that. We have the incoming wave, and then we have a reflected wave. Then you also have a diffuse reflection, and that's when something hits a rough surface. Again, we talked about this. Think about like a bouncy ball. If I threw it at a pile of gravels, it's not going to bounce right back at me. It's going to shoot off somewhere different. Here's what our images would look like. A virtual image is an upright image that forms where the light seems to be coming from. A real image is an upside down image that forms when rays actually meet. I'm going to zoom in here a little bit on the lenses so you can see what it looks like between your convex and concave mirrors. You have your focal points and then how the light rays reflect back. And that is it. I'll see you back in class.